Hey guys, welcome back. This is going to be the last set of notes we take in Chapter 8 for the test that's coming up on St. Patrick's Day. We will, once that's over, go back to the beginning of the chapter and talk about something called functions. A little preview there for you. So again, today's lesson is really all about the connection between solving equations and solving inequalities. So let's get into it. And to solve, and by the way, this is going to be 2 pages. It's probably going to might take me 2 screens to get the first page in. So I'll let you know when it's time to get to your second page. So to solve inequalities, unless you take the kind of room you need, we just usually put information on the left side of our 2 pages, and then on the right side do the practice. Follow the rules for solving equations. So to solve inequalities, we follow the rules for solving equations. So I'm going to get a little loud right now. Okay, ready? So we're going to do inverse operations. Inverse operations. To both sides of the inequality. Squish that in. Quality. Ooh, I did it. With the number that is on the same side of the variable. So again, just like we did before, we find the variable, there's math happening to it, we do the inverse operations, and that's how we solve it. Now, this is the one thing I keep seeing people do, and you cannot do it. Do not guess. This isn't a guessing game, which is what it was a lot of times in early, middle, or elementary school, because that's all you knew to do, okay? Now you're learning skills about properties of equality, that you can use them, all right? You don't show your work properly. I keep telling you guys this. This is what you're getting tested on. So you don't show your work properly, then you don't do well, okay? All right. So let me just remind you real briefly of inverse operations. So if there's addition going on in a problem, the inverse is subtraction. If there's subtraction going on in the problem, we're going to use addition. That's its inverse. If there's multiplication going on in a problem, we'll use division. And if there's division going on in a problem, we'll use multiplication. Those are the inverse operations. So what do we start with? We're going to do its inverse, which undoes it. So in the adding and subtracting, it allows me to create opposites. And when I add them, I get 0. So that's how I get the variable alone. When it comes to multiplication and division, I get inverses or reciprocals, and they give me 1. And when I multiply them by the variable, I just have the variable. So it's showing how the variable gets alone. It's not poof magic, it's math, okay? So we're going to look at 4 different problems. X plus 2 is greater than 5. We're going to look at x minus 3 is less than or equal to 7. Actually, you know what? I think I'm going to go to the next screen for this one, okay? I'm going to go to the next screen, and here's the reason why. Because we're going to solve these problems, but talk about steps one at a time. So you should still be near the top of your page. Maybe, I don't know, 1/5 of the way down. So we have x plus 2 is greater than 5. We have x minus 3 is less than or equal to 7. We've got 2x is greater than or equal to 10. And we've got x divided by 7 is less than 12. Okay? So we'll talk about steps and then we'll do that step. So we need to locate the variable. That's always where we start. Okay, now, generally speaking, the variables should be on the left side. I do not believe your book puts any variables on the right side, but that's going to happen starting next year. In order to solve any inequality properly, you need to have the variable end up on the left side. So you can use symmetric property and do it, but what gets tricky is if you flip-flop your equation, you got to flip-flop the inequality. But again, that is something for down the line. Okay, step 2. Once we find the variable, what's happening to it? So we're going to identify the operation. And again, you guys should be familiar when I say operation, I'm talking about mathematical, adding, subtracting, multiplying, dividing. That's what I mean by operation. Happening to that variable. This drives what math we get to do. Okay? And, no, let's not put that and, the number that the operation is working with. Okay, so let's look at our four inequalities. I'm going to rewrite them again. I think it's going to be a wet one today. At least that's what they keep saying. Okay. So I'm going to go highlight in this case so you can see what's going on. There's my highlighter pen. I think this is my highlighter. So with the x, nope, that's not a highlighter. If it is, I didn't do it right. Well, that's weird. Huh. Maybe that'll work. So with the x plus 2, I'm adding 2. Okay. So I'm going to write that down here. And then with the x minus 3, it's take away 3. And with the, this is the weird one. This is the hardest one to see because it's being multiplied. So I'm going to go ahead and put in a little dot for multiplication. Oops. Put a little dot. Oh, wow, that is not what I said to put in. That is so funny. Where's my pen? I seem to have lost my pen. That looks better. So this is going to be times 2 oh wow, I'm having trouble today. There, that looks better. So we're times 2. Oh my gosh. Alright, I don't know what's going on with my pen today. He's being all funky on me. Let's just change to this guy. And we'll erase all of those marks. Times 2. And then the last guy, we're going to just go ahead and highlight him. And it's this whole part here, which is divide by 2. Okay? So now that we know what we're doing, we can combat the problem. So step 3, get that a little smaller, sorry. On step 3, we're going to use inverse operations. With that number, to whatever number we've put down in the purple below. On both sides of the equation, in order to get the variable alone and solve the problem. Once the variable is alone, the answer's on the other side, right? Okay, so here we go. On, oh, wrong thing, sorry. On x plus 2 is greater than 5, we're going to do the opposite of adding 2 would be subtracting 2. So we subtract 2 from both sides. Okay? And we're not solving yet. See what we're doing? We're just going to write out step by step. So on x minus 3 is less than 7, we're going, the inverse of subtracting 3 is adding 3 to both sides of that inequality. And then, did I say equation? I always say that. I think I said the equation before. Yep. Let's change this word. See, it's so interchangeable that my math does that, or my mouth does that. So that would be inequality. I know I'd get grief over that one otherwise. Okay, and then the next guy is going to be the 2x greater than 10. So to show the inverse, we would divide both sides by 2. And for x divided by 7 is less than 12, we're going to show multiplying by 7 up high. Remember, we need to create a fraction with the same number in the numerator and the denominator, and that's what will make it go away. Okay, and then we're ready to solve it and write the answer. So we're going to write the answer, and it takes a particular format. Variable, inequality symbol, number. Okay? The reason why we want that variable first, so when we graph the answer, the inequality is pointing the direction to graph. So for the first one, we get x is greater than 5 take away 2 or 3. On the second one, we get x is less than or equal to 7 plus 3 or 10. On the third one, we get divide both sides by 2, we get x is greater than or equal to 5. And the last one, when we multiply by 7, we get x is less than 84. Now, because these are inequalities and there's infinite number of answers, we need to do one more step. Now we're going to graph the solution on a number line. Okay, so for the first one, and remember we talked about this in class, the previous notes, I only need 3 numbers on your number line if your solution is, or your starting point is an integer. Put him in the middle, and then one number in front of him, one number after him, so they're consecutive numbers like you would see on the number line. Remember how this works? We've got open or closed with greater than or less than. It's an open circle, so that says 3 is not an answer, but everything outside of the 3 is. Now the greater than is pointing to the right, so our graph goes to the right. Okay, so these are the things that I noticed. Open, right. Okay, next one, we've got x is less than or equal to 10. So again, just 3 numbers. If I have a fraction or decimal, I have 4 numbers, and the 2 middle numbers are going to be the number my fraction or decimal falls between. So 10 in the middle, 9 in front, 11 behind. Now, the inequality tells me to say, that's a closed circle at 10, because 10 is one of the answers, and then color to the left for less than. So closed circle, and we color to the left for less than. Next one, we've got x is greater than or equal to 5, so 5 in the middle, 4 in front, 6 in the back. And then or equal to says closed at 5. 5 is a solution, and we color to the right for greater than. So closed and right. And then the last one, number line doesn't get any bigger because I'm just putting 3 numbers on it. 84 in the middle, 83 in front, 85 in the back. It's just less than, so it's open, so it says 84 is not a solution, but everything to the left of it is. So open circle and color to the left. Okay? All right, so we just have a couple more examples where we're going to put the problems all together. So this is now the official page 2. So let's go ahead and retitle lesson 8-7, solving one-step inequalities. And we're at 3, 10, 20, 20. Okay, so the directions say solve, then graph the solution. So I've got 4, one of each operation, but we're going to add some fractions and decimals perhaps. So this one says x minus 1/2 is less than or equal to 2/5. So the inverse of subtracting 1/2 is adding 1/2. And then we have to deal with our fraction rules, which says we need to have common denominators. So it would be 2 times 5 or 10. So I'm going to multiply top and bottom of the first fraction by 2, so I get 4/10, bottom, top and bottom by 5, and I get 5/10. And I'm going to be adding. So the answer works out to be x is less than or equal to 9/10. So this is one where I'm going to put 4 marks on my number line. Let's see, 9/10 falls between 0 and 1. In front of 0 is a -1. After 1 is a 2. I'm going to arbitrarily make a mark. I'm going to label it as 9/10. And then we've got less than or equal to is a closed circle, and it's telling me to color to the left. So that's exactly what I do at the 9/10, and I color to the left. Be bold, color in that arrow cap like a triangle. That way I know exactly what I'm looking at. All right, next problem. We've got y plus 2.3 is greater than 8.2. So the inverse of adding 2.3 would be subtracting 2.3. So with my decimals, I remember I line up my decimal points. When I subtract, this goes away. We get y is greater than, and then I'm going to come over here. The decimal point's going to come straight down in adding and subtracting. Rename, and I get 12 take away 3 is 9, 7 take away 2 is 5. So again, I'm going to graph 4 numbers because it's a decimal. The 2 whole numbers that 5.9 falls between is 5 and 6. In front of 5 is a 4, after 6 is a 7. So I'm going to arbitrarily find where I think 5.9 would be, or a reasonable spot. And then I look at my inequality, and my inequality is greater than. So that means it's an open circle, and I color to the right. So open at 5.9, it's not a solution, but everything beyond it is. And there's that answer. And then number 3, we have 2m is greater than or equal to 1.5. So the inverse of multiplying by 2 is dividing by 2, so we show it this way. So remember, here I don't get a 0 like that, because that wouldn't make sense, because I get a 0. I get a 1, right? And so then I do my math, and I get m is greater than or equal to, and then off to the side, I'm going to do my division, bring the decimal point up. 2 can't go into 1, but it can go into 15 7 times, which is 14 with a difference of 1. Bring down the 0, and 2 goes into 10 5 times. So I get 0.75. So again, 4 numbers on my number line. 0.75 comes before, or between, 0 and 1. In front of 0 is -1. After 1 is a 2. I'm going to arbitrarily mark where I think 0.75 or 75 hundredths would be. And then looking at my inequality, greater than or equal to, says it's going to be a closed circle because 0.75 is one of the solutions, and I color to the right for greater than. So I do a closed circle. Sometimes it doesn't let me draw circles very easily. And then I color to the right for greater than. Make sure I can tell whether you're open or closed. And then the last question, I'll put right here. We've got 3/5 times the quantity, or times x is less than 12. So this is the one that most people struggle with. So I'm going to show you in the notes a different way of solving it. So the inverse, I'm multiplying by 3, I'm dividing by 5. So first thing I'm going to do is get rid of the denominator. And I'm going to multiply both sides by 5. So that goes, and that leaves me with 3x is less than 60. Now I've got a multiplication problem, so I'm going to divide both sides by 3. And that's going to give me x is less than 20. Okay, so now I draw my number line. 1, 2, 3, 20 in the middle, 19 in front, 21 after, and then less than says the answer is not a solution, so it's open, and I color to the left for less than. So at 20, it's an open circle, and then I color left for less than. And there you go. All right, have a good time with this, guys. We'll see you tomorrow. Bye.